Hello and welcome. In this video we are going to look at the actual process of manually doing logical volume management. So we're going to create a drive, mark it as a physical volume, put it in a volume group, and allocate space from that volume group into a logical volume. The last step to that, actually mounting that on our system, is a topic for the next video, but this will almost get us there. So we're going to see, as I just said, how we actually conduct logical volume management. And the whole purpose behind this is to allow us to more flexibly manage storage on our machines. Now, the first thing that we need to do is attach new storage to our machine. In the case of a physical machine, this would include plugging in a new drive. So, powering it off, opening up the case, physically putting that drive in. In the case of a virtual machine, we are just going to identify some storage. So I'm going to head to my demo machine here and do this using our virtual machine management software. So I'll go to the details view, add hardware, storage. This is probably the most common thing you'll be doing, so it's nice that it's right up at the top there. Identify the size of the disk that we're going to create. I'm just going to do something small. You wouldn't, in a real-world situation, probably be worried about adding 1 gigabyte worth of storage, but this is just to demonstrate how this works. Done. I now have VirtIO disk 2 for this machine that shows 1 gig worth of storage. Now, this isn't actually the machine I'm going to be demonstrating this topic on. I actually have another machine that I'm going to SSH into that already has this done. So I'm going to pause this video for a moment and actually do this on that machine, SSH into it, and then we'll continue. So I'll be right back. And I'm back. So I've gone to my virtual machine, there it is, and if we take a look at /dev, it now actually has 3 drives attached to it. If we can find that output, there's SDA, which is divided into SDA1, SDA2. There's SDB, which is divided into 4 partitions. So this is very much the same setup we saw in the previous video where I was talking about determining your drive structure. And I now have SDC, a 3rd drive that is attached that currently has no partitions. And this is absolutely something that we would want to double check, or we would use the lsblk or blkid commands that I already talked about, or SSM list or PVS, so we could make sure the drive that I'm about to work with, or the partitions that I'm going to create, I'm not messing around with one that is currently in use by the system, because that could cause all sorts of problems. So I know I want to work with /dev/SDC. So the first thing that I need to do before I can actually use logical volume management is I need to take this block device and mark it as a physical volume. Well, take this physical disk, create a partition in it, and that partition is a block device that I mark as a physical volume. So I will use fdisk to create a partition in this volume. I'm not going to go into absolutely everything that fdisk can do. I'm just going to cover some basics. I may at some point have to do a separate video on fdisk itself. So SDC being the disk that I just added. So sudo fdisk /dev/SDC. And of course, because we're working with drives, this is absolutely something we need elevated permissions for. Now, before we do anything else, it's actually already letting us know there's not a recognized partition table yet, because we just created this storage. The first thing we should probably do is hit M for help and get our menu. There's quite a few options here. The ones we will be concerned about are D, to delete a partition. So if we create one that we don't need, we can get rid of it. We might potentially want to list our known partition types. This is a shortcut that will allow us to not necessarily have to do pvcreate as a separate step. M to print this menu, of course. N to add a new partition. We will be doing that quite a bit. P to print the partition table. Always a good idea, both before you start making any changes. Look at the disk. Look at how it's currently laid out. In this case, I've just created a brand new one, but if I was to say work with SDB, I would absolutely want to print its current partition table before I start making changes. And in a moment, once I have made some changes before I actually make them permanent, I will print this table to double check that everything I've done is right. Potentially, I might need to quit without saving changes. That's a very nice thing about this command. While we're in this command and we're making changes, we haven't actually altered anything permanently yet. It's only once we exit this command with W to write and exit, it's only when we do that we actually write our changes to disk. Before we do that, if we realize we've made a mistake, we can always quit without saving, and we haven't broken anything yet. So I will print my partition table. As the thing said a few moments ago, this is a brand new drive. There is no partition table. There are no partitions. So maybe I would like to N create a new partition. By default, it's going to try to create a primary partition. That's fine. We can even just hit enter instead of typing in P. Partition number. Primary partitions, you're only allowed to have 4. There's no reason not to start with 1 and go up to 4. If you need more than that, certainly you could go with extended. But again, the next available one is going to be the default, so why not just hit enter and get 1. First sector is where on the drive this is going to start. You'll notice it's not quite at the absolute beginning of the drive. A little bit of space is taken up by that file system table. But yes, that is fine, the default of as early in the drive as I can get it. How much further along do I want this drive? You could add by sectors and start trying to do a calculation of how big you want your drive. You could say plus a size and then one of these scale units like kilobytes, megabytes, gigabytes. Or you could just hit enter and it will take up the rest of the drive. If I said perhaps plus 500 megs, so the last sector of this partition is 500 megs later than the first sector, so I will get a 500 meg partition. And because we're on Linux, it's defaulting to Linux, and yes, it's 500 megs. How do I guarantee that I've done that right? P to print the partition table. And now we see what it's going to do when I exit is create this device /dev/sdc1, so the first partition on the third drive starts at sector 2048, ends at 1026047. There's 512,000 blocks. It's a standard partition, or standard Linux partition. If this is what we want, we could W to write and quit. And now, if I take a look at /dev/, /dev, you can kind of see it on the screen there. On my SDC, I have now created SDC1. If we wanted to make changes, we can fdisk that drive again. Perhaps, well, again, we're working with a drive that already has partitions on it. Print that partition table, make sure you're working with the right one, make sure you're not breaking anything. In this case, that's not the drive that I want. So I'm going to say D to delete a partition. There was only one on it, so it defaulted to 1. If there were several, it would prompt you which one is it that you're trying to delete. And now if I print, it's now saying there's no partition on there. But wait, I realize, I didn't actually want to delete that yet. So I could quit. Just 1 Q, thank you. Quit without making any changes. And if I ls/dev, SDC1 is still there. If I go back and do this again, and I say D, I really should have printed before I did that. Fortunately enough, I was using my command history to get back to /dev/SDC, but I really should have printed first. Of course, if I was wrong, again, I could quit without saving. In this case, that is the change that I want to make, so I'm going to write. It's deleting that partition, and if I look in /dev, there is no longer an SDC1. It is gone. I'm going to go back in and actually make changes we're going to keep. So I'm going to, print, confirm I'm on the right drive. There's nothing in there. I want a new partition. Primary is fine. Number 1 is fine. First sector at the start. Great. I want, how about 250 megs? A tiny partition, but this is just to demonstrate how these commands work. More likely, we might be doing something with plus 250G. If I print, okay, I now have, it's going to create /dev/SDC1. But that's not the only partition that I want, so I'll say new again. Primary is fine. Now it's going to default to number 2. That's great. First sector is right after the end of the other one. That's probably okay. Potentially, you could want to leave some extra room if you might want to expand that first partition, but part of the point of logical volume management is we don't have to worry about that so much, because this space that we're allocating, we're just going to be adding that to a pool to reallocate later anyway. Last sector, I don't want the rest of the drive. I'm going to do another 250 meg partition. Okay, and, well, if I print, that's fine. I'm going to try to add a 500 meg partition to be the rest of the drive. And what you'll notice, primary is fine, partition number 3, start right after the other one, and I'm just going to hit enter and be the rest of the drive. Actually, if I say plus 500M, it's saying it's 500 megs. It will be a tiny bit short of 500 megs just because there wouldn't be quite enough space left. But if I print, it's saying it is 500 megs. Okay. I'm going to take this third one, /dev/SDC3, and instead of having to, as a separate step, PV create, we can actually change the file system type here under T. In order to do that, we're going to list the known types, because there actually is a specific type for a logical volume. So L, and what we're looking for is, I think it's 82 or 83. 8E. Linux Logical Volume Management. The other ones right now are currently set up as just plain Linux. But if I change my type to 8E, I'm already saying this is for logical volume management. So I'm going to change the type on partition number 3 to 8E. Changing it from Linux to LVM, and if I print, we can now see the first two are set up as Linux. This third one is Linux LVM. I'm happy with this, so I'm going to say write. And if I ls/dev, now I should have SDC1, SDC2, SDC3. So I have partitions that I'm almost ready to start working with. 2 of those, though, we still need to mark as physical volumes with this pvcreate command. So if I sudo pvcreate /dev/SDC1, it marks it as a physical volume. If we go back into our table, so we fdisk again, and I print, I could have sworn that would mark that as an LVM. Well, either one of these will work. I'm going to pvcreate SDC2. It's now a physical volume, so we have 3 LVM physical volumes. Once I have these, I can either create a new volume group or add them to one that already exists. To create a new one, the command is vgcreate. We give it a name, whatever it is that we're going to call it, and 1 physical volume to put in it. That will initialize it. That will make our volume group. If you have a volume group already and you just want to add more storage into it, it's vgextend, the name of that existing group, and the name of a physical volume to add. So if we go back to VGS, I already have archives and CentOS assign 1. I'm going to make a new volume group called demo. vgcreate demo, and the volume that I'm going to put in it, /dev/SDC1. Successfully created. And if I run VGS, there it is. I have demo, and it's about 250 megs. If I want to add a volume to it, sudo vgextend demo and the name of the volume that I want to add, SDC2. Create it. If I want to extend it further, let's add SDC3 in there. Okay, in this case it's setting it up as a physical volume. I guess that changing the flag in fdisk did not work. You do need to run pvcreate. In this case, maybe because I had the flag, it was able to cover for me and effectively do pvcreate for me. So now if I look at VGS, in that demo, I have 3 physical volumes, a combined size of just short of a gig. If I want to take a physical volume back out of a volume group, the command to do that is vgreduce. Keeping in mind this is only going to work if there's already enough storage, or there's still enough storage in that volume group to meet all of its needs. If I have a 1 gig volume and I've only, a 1 gig volume group, and I have allocated 200 megs to a logical volume, yeah, I could shrink that volume group by 500 megs without issue. But if I had allocated 800 megs to logical volumes, and I tried to shrink this 1 gig volume group by 500 megs, it's going to tell me, you can't do that, you're using that space. So I would need to reclaim that space first. But the nice simple case of it, we can sudo vgreduce whichever volume we want to take back out, well, pardon me, the name of our volume group and the volume we're taking back out. Remove that from the volume group demo, and if I look at VGS, well, now there's 2 physical volumes in there, and the size of that volume group dropped by 250 megs, roughly. So now I have a volume group. I have this pool of storage that I can start using. So now I will allocate some of that space as a logical volume with LV create. So, and of course we'll need sudo for this, so LV create -- size, a number, and a unit, so we can specify how big this is, and a scale, for example, 500 megs, 200G for 200 gigs, 10K if we wanted a really tiny volume. Alternatively, you may see people use -L. That works. I generally recommend the -- size because that's very, very clear what the option is. You'll use -N to give this logical volume a name, a human readable name, so you know what this logical volume is, and you'll tell it the volume group that it's being created in. So I will sudo LV create -- size. I've got 744 megs to work with, so I'm going to say 500 megs. -name. I should have thought of a name before I started my demo. And it's also just -N, not -name. -name. I don't want to use demo because that's the name of my volume group. I want to make sure this is very clear what it is. So I'm going to say demo LV, demo logical volume. And that's going to exist in the volume group demo. Logical volume demo LV created. If we take a look back at VGS, it's now going to let us know I have now created a logical volume in that volume group, and of the total size of the volume, you'll notice the amount free has changed because I have now allocated 500 megs of that to a logical volume. That logical volume is just about ready to use. I do still need to actually write a recognizable file system into it before I can use it. I'll do that with mkfs make file system. So mkfs -t, whatever file system type, for example, ext4, xfs. If your system knows about it, you could use xfat or ntfs if you really wanted to. And we give it the path to the logical volume, which is you can find this, or you can just use /dev, the name of the volume group, the name of the logical volume. So sudo LV create. In my case, I'm going to do ext4, and that's going to be created in /dev /demo demo LV. So /dev, that directory that holds your devices, demo be in the volume group, demo LV, the logical volume we just created in that volume group. Which option did I forget? Oh, I'm supposed to be running mkfs, not LV create. There we are. And it says it wrote and it's done. So yes, absolutely read the feedback from your commands. With that, I now have a formatted volume that I can now attach to my system and start using. The actual steps of mounting this onto my system I'm going to leave for a separate video, because that will work whether it's a logical volume or a illogical volume. So we'll deal with that separately. There's already quite enough in this video. Just before we end though, you might potentially need to change the size of a logical volume at some point. When we want to do that, there are 3 commands that we can pick from, which, well, really it's one command and 2 alternate versions of that command. LV reduce allows us to shrink a logical volume. LV extend allows us to expand or grow a logical volume. LV resize allows us to do both. reduce and extend are just specialized versions of LV resize. When we use this, you will almost always want to include this -r if you have a file system inside your logical volume already, so you've done this step to make a file system, this will resize that file system as well. So for example, if you're shrinking a logical volume, you would want to make sure that file system fits within the new size. As long as you're not using the space, the system will be able to shrink it for you. Or if you were growing your logical volume, the reason you're growing it is because you need more space, so you probably want to grow the file system that's inside it to match that space. So include the -r to resize the file system as well. We'll again use --size with a size and a unit the same way that we worked with back in LV Create. So you could do things like, say, 2G or 100M for 2 gigs or 100 megs. You know, it's a number and the scale for that number. Optionally, you might include a plus or a minus with that, with the warning that LV reduce only allows the minus, LV extend only allows the plus, LV resize allows both. If you don't use the plus or minus, for example, if you said LV reduce --size 1G, you are saying shrink this logical volume so that it is 1 gig. If you said LV reduce --size minus 1G, you're saying shrink by 1 gig. So if it was 500 gigs and you say minus 1G, it's now 499 gigs. Whereas if you just said LV reduce --size 1G, your 500 gig volume suddenly becomes a 1 gig volume. And this is where LV reduce and extend are somewhat handy. They won't allow you to resize the wrong way. So if you had a 100 gig volume that you were trying to grow to 500 gigs, and you said LV reduce 500G, it's not going to let you do that. If you said minus 500G, it's probably still going to complain because there's not 500G to shrink by. Let's actually see this in a terminal. So I have my, that's LVS, pseudo LVS. I have my demo LV, that is 500 megs. I would like that to be bigger. So I can sudo LV extend plus 100 megs. That should be --size plus 100 megs. I should remember to include the -r to resize the file system that's inside it. If you forget to do that, there's a separate command that you could use afterwards, but I'm not going to cover it. You could look up the man page or research that on your own, or just make sure you remember to resize all the time. So plus 100 megs, I know I'm forgetting an option here. Right, the name of the logical volume. Demo LV. Oh, path to the logical volume. Dev volume group logical volume. There we are. And if I sudo LVS, it now shows up as 600 megs. So if I were to say, just to demonstrate using plus or not, if I say LV resize, if I say plus 100 megs, I should end up with a volume that is, 600 plus 100, 700 megs. There we are. That shows up. If I say LV resize, maybe I wanted to grow this to 800 megs, but I leave out that plus, I'm saying resize to 100 megs. So it is going to try to shrink this volume down to be 100 megs. And because I don't actually have anything in it, there's nothing using up that space, it worked. And if I sudo vgs, now I have 644 megs that I can use for something else. Just a note, when you are working with your volumes, when you're expanding your storage, you always have to work from the outside in. That is, you always have to create the new storage first, so plug in a new drive, make that a physical, well, possibly partition it, make it a physical volume, add it to the volume group, and then expand your logical volume. If you're shrinking storage, you have to work from the inside out. So you have to shrink your logical volume, probably shrinking the file system inside it as you do. Then, once you've freed up that space, you can shrink your volume group so you're no longer allocating X amount of space, and then you can remove a physical volume from that. If I LV resize back up to 700 megs, there it is, I'm using it, that volume group only has 44 megs free, and I try to, let's scroll back up through my history, and try to remove one of my physical volumes. There it is. It's not going to let me do this, because that's in use on my system. There's not enough free space. So what I need to do is shrink my system, resize to 200 megs, then it can remove that volume, because there's still enough space left in my volume group, if I take it out, to be able to still meet all of that volume group's allocated storage. And I've still got almost 300 megs free. So what we've looked at in this, and another 32-minute lesson, I try to keep these short, but you know, when you're dealing with these, they do tend to make sense if you do one thing immediately after the other. So we've looked at the actual practical aspects of the commands we use to set up LVM on our systems, including, well, creating that logical volume, making it a plugging in a drive, making it a physical volume, adding it to a volume group, and then making a logical volume from that the space in that volume group. We also looked at how you can resize, reallocate. So this is going to allow us to, as I just did at the end here, flexibly configure our storage. We can swap drives in and out. We can add space as we need it. If we realize one of our volume groups has a bunch of extra space that we need elsewhere, we can just pull that space out of that volume group and quickly and easily reallocate it to another. So absolutely, it's a little bit of extra work up front, but it pays off in the long run. Once again, I've got a link to a really good tutorial on LVM that I will put in the description. So the last step to this, now that we have this logical volume that I've marked as a file system, I still have to attach to my system. That's the topic for the next video. I will see you there.